hello sir. Join college is minimum होता है चला करता है तो बड़ा आश्चर्य
Welcome to all learners of Indira Gandhi National Open University. I wish you all a happy and prosperous New Year 2021.
Same to you, sir.
Thank you.
Same to you, sir.
Actually, before going to start my class, I give my introduction that myself, Mr. Ashok Kumar Das, reader in mathematics, Kendrapada Autonomous College, Kendrapada. Is it audible to you?
Yes, sir.
Thank you. Now we are going to start a chapter that is the course code of IGNOU, that is your BMTC-133, which includes the chapters that is your mathematical statements and task symbols. Everybody knows the mathematical symbols perhaps. There are so many mathematical symbols, and before starting this one, we will discuss about what is mathematical statements first. Perhaps in the lower class, all you know what is mathematical statements. Mathematical statements means a statement which is either true or false is, or any sentence which is either true or false is called as a statement. First of all, it is just sentence. Secondly, after reading this, if you know it is true or it is false, not both at a time. If it is true, the sentence is true, then it is a statement, or if it is false, then it is also a statement. So what do you mean by a statement? A statement a sentence or a declarative sentence which is either true or false is called as a statement, or simply it is also called as a proposition. Statement or proposition have same meaning. First of all, I am going to say what do you mean by a statement. There are two things. First is it is a sentence. Secondly, after reading it, if you know that it is true, then it is a statement. If after reading this you know that it is false, then it is also a statement. But the same type or the same time you can't say it as true or false. And that true or false is called as the truth value of that statement. For example, sun rises in the east. This is a sentence. And after reading this, we know that it is true because the sun rises in the east. Since this is a sentence and which is true, so that this sentence is called as a statement. Do you follow me? Anybody?
Yes,
Okay. If I write that sun rises in the west, is it a statement?
yes, sir.
It is also a sentence and which is false. So that it is also a statement. Statement means, first of all, it must be a sentence. Secondly, it is either true or false, not both at a time. If it is true, then it is a statement. If the sentence is false, then it is a statement. So the first kind of, when I say that the sun rises in the east, it is a sentence and which is true. So that it is a statement and the statement have the truth value that is true, or it is written as capital T. The symbol for true, we use capital T. And when the sentence is false, then it is a statement. And for that false, we use a symbol that is capital F. And that T and F both are the truth values of the statements. Next is for example, there are so many sentences to which you can't assign any truth value, that is either true or false. There are so many sentences, but after reading this, you can't say whether that sentence is true or that is false. Those sentences are not statements. Those are example. That is the Mumbai is a big city. Can you say whether it is true or false?
No, sir.
Because there is no yardstick for big city, or if there is some yardstick that is, but to be a big city, if it has some number of populations, some buildings, or some number of vehicles are used there, there is no such yardsticks or the measuring rod for to be a big city. So that sentence is neither true nor false. You can't assign any truth value to that sentence. That is true or false. So that sentence is neither true nor false. So it is not at all a statement. So statement means, first of all, it is a sentence. Secondly, after reading it, you can assign a truth value, or you can say it as true or false. Then that sentence is called as a statement. So statement means it is a sentence and which is either true or false. If it is true, then its truth value is capital T. Symbolically, we write it as capital T. If it is false, then the truth value is false, or symbolically we write it as F. Then is your then after that we can use logical connectives. So connectives are conjunction, disjunction, conditional, biconditional. These are all connectives. Connectives means, for example, how will you use it? How we can use these connectives in the statements? For example, I say that sun rises in the east, or man is mortal. These two are all statements because these two are sentences and which both are true. Sun rises in the east, it is true. Man is mortal is also true. For this sentence, since it is true, so it is a statement. So for that statement, we use some symbols. To identify the statements, we use symbols. That symbols represent that it is a sentence and which is true or false. Since it is a statement, so it is either true or false. First of all, it is a sentence. Secondly, after reading it, we can say that it is true or false. So that those symbols are used for the statements. That is your English alphabet, that is small p, small q, and small r. These are used for the statements or to represent the statements. When we say that P, it implies that it must be a sentence and it must be either true or false, not both at a time. If I write it as when man is mortal, then that P will be a sentence and having truth value T. If that P represents for 2 plus 3 equal to 7, that is also a sentence, but that is false. 2 plus 3 is equal to 7, the sentence is false, so that it is also a statement. So that this statement has truth value F. If I write simply P, it symbolizes that it is a statement and it has either one truth value T, or if it is not true, then it is false. If it is true, then it is not false. If it is false, then it is not true. But it has truth value any one of them, either true or false, not both, not and. It is true or false. And Q, if it is a statement, then it is a sentence and it has some truth value true or false. If R is a statement, then it is a sentence and it has some truth value true or false. So small p, Q, and R are used for statements, symbols used for statements. And T and F are symbols used for the truth values. So T and F are truth values of a statement. So how we can use the connectives? Connectives are conjunction, disjunction, conditional and biconditional, and one of the connective that is called as negation. So when first of all, if I write P such that P is a statement hello? Hello?
Yes, sir. Yes, sir.
Am I audible to all of you?
Yes, sir.
But what I am saying, do you follow it?
Yes, sir.
Okay. Actually, what I am now teaching you, actually in the lower class, some courses was this relating to this mathematical induction or mathematical reasoning. So that it is also the course which is included in your degree level also. Actually, this is also in the some of the books of 12 classes. This course is also, it has a little course, but in your degree course, it is more than that. Okay, when I am saying that two statements are used to combine, or we can use the symbol conjunction. Conjunction means it is in the language form. Conjunction means it is and. When we are joining the two statements, for example, that is sun rises in the east, it is a statement. Let it be P, so that it has truth value true. Sun rises in the east. Then is your Q is a statement such that Q means, for example, 2 plus 3 equal to 7. It is another statement and it has truth value false. When symbolically we use the connective conjunction or and or P conjunction Q or P and Q, it has some rule. Since P is a statement, but P since a statement, when we write sun rises in the east, it is true. It has truth value T. But simply when I symbolically use P, what truth value you can say it? You can say either true or false. Any one of these two. But when I write the statement clearly, you can exactly assign whether it is true or false. But when we use symbols, then we can write either true or false. It has two types of truth values, maybe true, maybe false. So that when I say that P conjunction Q means we have to write a truth table. That in the tables in which truth values are written, those tables are called as truth tables. For every connective, we have to use or we have to write a truth table. First of all, when we are writing P, then we can write the truth value T or false, true or false. When we write Q, then it has truth value T or F, true or false. When combined we write two statements, how many types of truth value can be possible? Anybody? When we are taking two statements at a time, how many types of truth values we can write it? Anybody?
Two.
We can write four types of truth values. When P has possibilities 2 and Q has possibilities 2, so that P and Q both have possibilities 4. That is both true. It is possible both may be true, or first true next false, or first false next true, or both false. Do you follow me?
Yes, sir. Yes, sir.
But this conjunction, when we use the connective, that is conjunction between two statements P and Q, that is P conjunction Q, it has the rule or law that is when both statements are true, at that time the conjunction is true. Otherwise it is false. Do you listen me?
Yes, sir.
Well, first of all, we will write that is 3 columns. That is in one column that is P, in another column that is Q, in the third column that is P conjunction Q. That is when P and Q both are true, then the conjunction will be true. That is when P and Q true means PT and QT, then P conjunction will be true or T. In other rows, first we will first naming the statements, that is one row. In another 4 rows, we will write the truth values of P and Q. That is your TT, TF, FT and FF. Then that is the third column, first column P, second column Q, third column that is P conjunction Q. In the first row, only we can write T, but in the other 3 rows, we will write F, because the rule for conjunction is the conjunction, a rule for conjunction is a conjunction statement is true when both statements are true or their prime statements are true. Otherwise, it is always false. So in the first line or first row, there is P true and Q true. So in the first line of P conjunction Q, you will write T. But in the rest of the 3 rows, we will write F. Next is your disjunction. That is OR. If P and Q are 2 statements, then we write P disjunction Q. That's first in the, therefore we can write a table. In the first column, we will write P. In the second column, that is Q. And the last column, that is P disjunction Q. The rule for disjunction is, a disjunction is false when both are false, otherwise true. Disjunction is false when both statements are truth value false, otherwise the disjunction is true. So if you write 4 rows assigning the truth values to P and Q, the TT, TF, FT and FF, what truth value will be written in the last column, that is the third column, that is the P disjunction Q? Anybody who can say?
Please repeat once again.
For example, we will construct or we will write a truth table for P disjunction Q. Disjunction is another connective, and that connective is used to connect both the statements. Since the statements have truth values, we are taking, because the disjunction cannot be used with a single statement. This
Yes,
this connective will be used in 2 statements. That's PQ or QR or PR. That is, it is called as P disjunction Q or Q disjunction R or P disjunction R. First of all, we are taking 2 statements, P, another statement Q. So forming that table or writing the table for P disjunction, first of all, we will form a table having 3 columns. In first column, that is P. In the second column, that is Q. In the
third P disjunction Q.
Exactly. Very good. In the third column, that is P disjunction Q. P disjunction Q. Now I am seeing the screen, that is whether how many number of learners have joined. Perhaps 2. You have joined perhaps 9 learners or 9 students. Okay. Now I'm repeating that thing. That is your P disjunction Q. The rule for disjunction is, a disjunction is false when both statements are false. Otherwise,
Yes, sir.
Otherwise
I
true.
got it.
When we are simultaneously we write the statements P and Q having truth value TT, TF, FT and FF in 4 rows. The last row contains both F, so that in the last row of a P disjunction Q, it is false. But above all this, above 3 rows, it is true. This is the rule for disjunction.
Sir, in P conjunction Q, in last row FF, then the P conjunction Q is F, no?
If only it is true when both are true. That is, in the first row, it is simply true. But below that row, all the 3 rows have the truth value F in case of conjunction. But in case of disjunction, the last one is false. But above the last one, all lines have truth value true or T. For truth values, you will write capital T for true and capital F for false. Then is your, do you follow me?
Yes, sir.
Okay. Perhaps it is easy for you. All of you will feel the easy chapter for everyone. Next is your, there is another connective, that is your conditional, or we sometimes it is called as implies, or in form of language it is called as if then. If then. For implies, what does it mean? That is also called as conditional, and or it is called as, in language form it is called as if then. And implies is used in many parts of mathematics. When there is some condition for the below statement is a, for that the above statement is one condition. Okay, for example, I am writing as if 2x is equal to 10, then x is equal to 5. So for x is equal to 5, the condition is 2x is equal to 10. That is when 2x 10, then x must be equal to 5. Do you follow me?
Yes, sir.
Okay, that for conditional statement, we will write that if P and Q are two statements, and P, since P statement, it may be a true or may be false. If Q is a statement, it may be true or it may be false. Then when P and Q simultaneously we are taking these two, we can write four truth values, that is TT, TF, FT and FF. But the rule for this conditional is or implication, it is called as implication or conditional, or it is also called as if then. For that conditional, the rule is a conditional is false when first statement is true and next statement is false, otherwise true. When we are writing that P implies Q, then the first statement is your P and the next statement is your Q. But when we are writing Q implies P, at that time Q is the first statement and P is the second statement or next statement. So that a conditional is false when first statement is true and next statement is false. If I write in the four rows, that is your TA, T and TF, FT and FF, can you say in which row I shall write F and in which row I shall write true? Anybody?
Sir, in TF we can write false.
Exactly, very good. In the second
And
row,
second
you
row.
can write F. In all other rows, we will have to write true or T.
T, T.
Only that is TF, so that we can write that is F in the second row and true in all the other three rows. If I will write another column, that is Q implies P. I had written the truth values, that is your TFTT. In case of P implies Q. If I write Q implies P, in what row I will write F and in what row I will write true?
In third, so in third row, I think.
In the third row, I shall write F, but in all other rows, I shall write true. That is Q implies P. Next is your, this is the rule for decision, sorry, conditional. A conditional is false when first statement is true and next statement is false. Then is your biconditional. Biconditional means the rule for biconditional, or it is called as implies and implied by, or if and only if. So in case of biconditional, in case of biconditional or implies and implied by, or it is called as if and only if. The same meaning. Biconditional, it has meaning if and only if, or implies and implied by. That is, it is the combination of two implications. That is your biconditional. It is the combination of two implications. So that in case of biconditional, it has rule that a biconditional is true when both statements have same truth values. If both statements have same truth values, At that time, we write that the biconditional statement is always true. If both statements have no same truth values or different truth values, at that time the biconditional is false. So for that biconditional, we have to form a truth table. In that truth table, we can write first one in the first column P, in the second column Q, in the third column that is P biconditional Q, or implies and implied by. In that biconditional, we have to write the truth value that is true if when both prime statements have truth values same. Either it may be true or it may be false. But in that case, we can write the biconditional is true. But in other cases, that is when one is true, another is false. At that time, we write that the biconditional is false. So the rule for biconditional is a biconditional is true when both statements are true. Otherwise, it is false. If I write when we are taking two statements simultaneously, that's P and Q, and P has truth value T or F, and Q has truth value T or F. Join. Dear learners, I request you to write your enrollment number in your chat box. That's why it is recorded that you have joined in the virtual class. Please enter your number, enrollment number. Is it audible to you? Hello?
Yes, sir.
Okay. Then we'll start. Well, first of all, when we are going to form a table for biconditional, first in the first column there is P, in the second column there is Q, in the third column there is P biconditional Q. When we are taking simultaneously both the statements P and Q, so it has truth value 4 types. That is your true, false, true and false.
False.
But when we write the truth values in the column of P biconditional Q, by adopting that rule, that is the biconditional is true when both statements have same truth values. So in the line that is in the first line, since both P and Q has truth value T, so we will write it true in that line. And the last line, both P and Q are false. So that in that line, we also can write it as true. But in the middle, second and the third line, we'll write they are false. Because in these two lines, both the statements have no same truth values. They have different truth values. So that in the middle or second and third line, the truth values of P biconditional Q are false. But in the first and last line, the truth values of P biconditional is true. So this is the table for biconditional. So adopting the rule for biconditional, that is the biconditional is true when both statements have same truth values, otherwise false. But in case of negation, if P is a statement, negation means it is in form of language, it is not. Not means Uday Kiran.
Yes, sir.
Please switch up your microphone.
Sorry.
Hello. Now, we have discussed 4 truth tables. That is truth table for conjunction, then disjunction, then conditional, then biconditional. Then there is another connective, that is negation. If a statement of truth value true, when we write negation in that statement, then it has opposite truth value. If it is true, then it is false. If it is false, then it is true. Oh, first of all, when I am saying that man is mortal, if it is the statement P, then it has truth value T. If I write negation in this, that is man is not mortal, then it is false. So that when a statement is true, then its negation is false. If otherwise, when the statement have truth value F, then its negation is true. So these are the truth tables or truth values for different connectives. That is negation, conjunction, disjunction, conditional and biconditional. Then is how to find truth tables for different when we are writing the truth table. But now I have discussed about the truth tables for different connectives. But for example, I am writing another table, that is a P conjunction, Q disjunction R. But for that statement, we will write truth table. We'll write truth table, and we'll at that time we'll form different columns. That is your P conjunction, Q disjunction R. There are two connectives and three statements. In that stage, we will write columns. When we will write or we will form the table for P conjunction, Q disjunction R, there are prime statements, are three prime statements. In that three prime statements, how many number of rows we can form? Anybody who can say? How many different rows we can form? We can form 8 rows, because P has truth value T or false, true or false, Q has truth value true or false, and R has truth value true or false. Simultaneously, when we are taking 3, then we have to form 8 rows. We have to form 8 different rows. How it is possible? For example, you have a coin with you in your hand. If you toss it, then how many different outcomes are possible?
So 2.
2. If you have 2 different coins and you toss it,
4.
then how many different outcomes are possible?
4.
4. If there are 3 coins in your hand and you will toss 3 coins at a time, then how many different outcomes are possible? 8. Actually, if in 2 coins, in case of 2 coins there are 4. In case of another coin, you write another head or tail. First of all, in the 2 coins there are 4 types of head or tail. In that 4, first of all you write in all cases tail, and in another same repeatedly writing all cases head. So there are 8 outcomes are possible. For example, a die is tossed. For example, a die is tossed. There are 6 faces in a die. So if you toss a die, then how many outcomes are possible? How many outcomes will be possible in case of tossing a die?
6.
If 2 dice are tossed once, if 2 dice are tossed once, 36. If 3 dice are tossed once, there will be another 6 will be multiplied with this one. 6 into 6 into 6. That is 36. Outcomes are possible. That is 36 into 6 will be the number of outcomes. That is 216 in case of 3 dice. But only 36 outcomes in case of 2 dice. But only 6 outcomes in case of 1 die. 1 die, if you toss 1 die, then there will be 6 outcomes. If you toss 2 dice, that is 36 outcomes. In case of tossing of 3 dice, there will be 6 into 6 into 6. That is 216 outcomes are possible. Okay. Okay, when we are writing P conjunction Q disjunction R, first of all we will write 8 rows. Then we will write another column. First column is your P, second column is your Q, third column is your R, and then P disjunction P con. First of all, Q disjunction R is another column. Then is your P conjunction Q disjunction R is the last column. So there will be 5 columns but 8 rows. And in case of this, you will compare all these one, that is P and Q and R, will write 8 rows. And then when we will write Q disjunction R, you will see only Q and R column. And disjunction has rule that a disjunction is false when both are false, otherwise true. So you write the column Q disjunction R obeying that rule. Then you will see the column that is your P conjunction Q disjunction R. That is, you will see P and the column and the Q disjunction R column and compare with that rule. Then we will then is your we will see the column P and the column Q disjunction R and compare with the rule that is conjunction is true and both are true, otherwise false. That is when we will see the column P and column Q disjunction R and write obeying that rule. That is a conjunction is true when both statements are true and otherwise false. This P conjunction Q disjunction R is also equal to, that is P conjunction Q disjunction P conjunction R. If we will write or form a truth table and compare P conjunction Q disjunction P conjunction R with P conjunction Q disjunction R in each column, compare these two columns, and in each row P conjunction these two statements have same truth values, so that P conjunction Q disjunction R is equal to P conjunction Q disjunction P conjunction R. Do you listen me? Am I audible?
Yes, sir.
Okay. Actually, there are two things. And one is your prime statement and other is your composite statement. Prime statement means any statement without any connective is called as prime, or it is also called as simple statement. Composite statement means any statement or statements with connective or connectives is called as a composite statement. I am writing P conjunction Q, it is a composite statement. Only P, it is simple or prime statement. Only Q, it is a prime or simple statement. Only R, it is a prime or a simple statement. But P conjunction Q disjunction R, this is one statement, but it is a composite statement because it has two connectives. Simply, if you use connective in the statement, it is called as composite. Without using any connective, it is called as a simple statement. Then is your, that is, if a composite statement have truth values always true, those composite statement is called as tautology. Do you know what is tautology? A tautology, a composite statement having all truth values true is called as a tautology. That composite statement is called as a tautology. Next is your, when we are writing that is P conjunction Q disjunction R or any composite statement and comparing all the truth values below the composite statement, if it is all the truth values of that composite statement is true, when we write or we say that that composite statement is called as a tautology. The very definition of tautology is if the truth values of a composite statement is always true, irrespective of the truth values of their prime or simple statement, then that composite statement is always called as a tautology. Next, we switch up to your that is called as the real numbers. Do you know what is real number? Anybody?
So numbers starting from 1.
First of all, before going to real number, I am saying that in case of number system, the smallest set is that set of natural numbers. Natural number means the set containing the elements 1, 2, 3, 4, 5 up to infinite. The smallest element of the set of natural numbers is 1. And it starts from 1, but it has no end value. It is an infinite set. Do you know this is the set of natural numbers? That is, it is written symbolically capital N. Capital N is the set of natural numbers. That is 1, 2, 3, 4 up to infinite. Then we go to the set of integers. Set of integers includes all the elements of the set of natural numbers. That is, it contains the elements that is your 0, plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 5, up to plus minus infinite. If 0 is the middle point, towards right of the 0, we write the positive numbers or positive integers. That is 0, then 1, 2, 3, 4 up to infinite. In the left of 0, we write that is your minus 1, minus 2, minus 3 up to minus infinite. This is the set of integers. Do you follow me? Hello?
Yes, sir.
Then we go to the set of rationals. Can you say whether set of natural numbers in the case of set of natural numbers and the set of integers, which one is the larger set? Whether the set of integers or the set of natural numbers?
Sir, natural numbers.
No. The set of integers is the larger one. And the
So
set
because
of
it includes both negative and positive.
okay. The set of integers contains both positive and negative numbers and including 0. But a set of natural numbers, it does not contain 0 or any negative integer. It contains only positive integers. Set of natural numbers contains all the positive integers. But the set of integers contains all the positive integers, all the negative integers, including 0. 0 is an integer which is neither positive nor negative. 0 is a special integer which is neither positive and not negative. Okay, so the set of natural numbers is the smaller one, but the set of integers is the larger one. So that n is a subset of z. Do you know what is the very definition of subset? Subset means two sets you have given, A and B. If each element of A also an element of B, then A is said to be the subset of B. Do you follow me? Hello?
Yes, sir.
Okay, I am giving an example. Suppose A set has elements 1, 2, 3, 4, 5 and B set has element 1 to 100. So all the elements of A are also in the set B, so that A is the subset of B. But all the elements of B are not included in the set A, so that B is not subset of A, but A is the subset of B. Since all the elements of set of natural numbers are also in the set of integers, so that the set of natural numbers is also a subset of the set of integers. Do you follow me? Hello?
Yes.
Then we go to the set of rationals. Rationals means it is a set, the set of rational numbers or rationals, it is a set containing the elements like P by Q, where P and Q both are integers, but Q or the denominator is not equal to 0. Any number which can write in this form or we can express in this form, then that number is called as a rational number. For example, 2 by 3, 4 by 5, 10 by 9, minus 3 by 2, all these are rationals because they are expressed in the form of P by Q. so that it is a rational number. The 0, it is also a rational number because it can also be written in the form of p by q. That is 0 by 1, 0 by 2, 0 by 3. So these are also rationals. So 0 can be expressed in the form of p by q, where p and q both are integers and q is not equal to 0. We know 0 by any non-zero number is always equal to 0. So 0 by 5, 0, 0 by 10, 0, 0 by 100, 0. So that 0 is a rational number. And every fraction, that is 2 by 3, 4 by 5, 10 by 9, all these fractions are also rationals because they are expressed in the form of p by q, including or obeying the rule that is p and q, numerator and denominator both are integers and the denominator is not equal to 0. So that in this case, since every rational means it can be expressed in the form of p by q, but there are some numbers which are real numbers, but they can't be expressed in the form of p by q, like the numbers root 2, root 3, root 5. Those numbers you can't express it in the form of p by q, or it has some numerator and some denominator, and numerator and denominator are integers, non-zero integers. So this number root 2 and root 3 or root 5 or root 7, they cannot be expressed in the form of p by q. So they are not rationals. For that, these numbers are called as irrational numbers or irrationals. So the number which can be expressed in the form of p by q, they are rationals. And the numbers those can't be expressed in the form of p by q, they are irrationals. And the union or the combination of the set of rationals and irrationals, or the union of the set of rationals and irrationals, the set is called as the real number set. We write or represent the set of rationals in symbolically, that is q, and q dash represents the set of irrationals, and q union q dash, or the union of the set of rationals and irrationals, is the set of real numbers, or that is capital R. Q union q dash, that is capital R. So in case of number system, the smallest set is n. From n, there is another some larger set, that is set of integers, or z. Z is the symbol used for the set of integers. And from z, there is another larger set, that is q, which is the set of rationals. And from q, there is another larger set, that is r. So that n is a subset of z, z is a subset of q, and q is a subset of r. So the set of natural numbers is a subset of the set of integers, and the set of integers is always a subset of set of rationals, and the set of rationals is always a subset of set of real numbers. Do you follow me? Hello?
Yes.
Can you say the set 5 is an element of set of natural numbers? Like
Yes,
the
sir.
same 5 is also in the set of integers. The same 5 is also in the set of rationals. Can 5 be expressed in the set of in the form of a rational, or in form of p by q, where pq belongs to z and q not equal to 0? How it can be expressed?
So 5 by 1.
Very good. It can be written in the form of 5 by 1. That is, or 10 can be written as 10 by 1. So that 10 is also a rational number. So every integer, whether it may be a positive integer or may be negative, or it is 0, it is always a rational number because it can be expressed in the form of p by q. That it can be written in the form of p by q means that the same number divided by 1. But 0 can be expressed, any positive integer or negative integer can be expressed in the form of p by q, that is the same integer by 1. But 0 can be expressed in different form, that is 0 by 1, 0 by 2, 0 by 100, 0 by 1000. That is always equal to 0. 0 by any non-zero number is always 0. So it is expressed in the form of p by q, and pq both belongs to z and q not equal to 0. Numerator may or may not be equal to 0, but denominator can never be 0. If denominator is 0, then that cannot be, that number does not exist, or this cannot be found. But when we are writing any integer in form of rational, so every integer is also a rational number. Every integer, whether it may be a positive integer or negative integer or zero, they can be written in the form of p by q. So that every integer is also rational. So in set of integer is a subset of set of rationals. Since the set of real numbers is the union of set of rationals and irrationals, so the set of rationals is the subset of set of real numbers. So in number system, n, z, q and r, n is the subset of q, q is the subset of, sorry, n is the subset of z, z is the subset of q, and q is the subset of r. So in case of number system, r is the largest set, which contains all the elements of n, all the elements of z, and all the elements of q. So in case of number system, n is the smallest set and r is the largest set, and n is the subset of z. Z was natural number set is the subset of set of integers. Set of integers is the subset of set of rationals, and set of rationals is the subset of set of real numbers. Do you follow me?
Yes,
Hello?
sir.
It's the time to end your class. But I feel you have already followed me in some way. Thank you all. We will meet in another class. Thank you all.
Chat section enrollment number.
Now I request all the learners to write your enrollment number in the chat box. It will be helpful to us to make your attendance. Please write your enrollment number in the chat box. If anybody has written, then ignore it. If you have not written it, then please write it now. चल